Hello guys, welcome again. This is a super fast review about general sequences, specifically arithmetic sequences. So first, the very basics, we must know that a sequence is a list of numbers, okay, that follows a certain rule. Okay, so what is this? When we have a list of numbers like this one, 3, 6, 9, 12, 15, these numbers are following a rule. Okay, we can find the next number by adding 3. Okay, so we can say from 3 to 6 we have 3 plus 3 plus 3. So this is the meaning of following a rule. Each number of the sequence, each number is a term. So this is a term, term, term. Okay, every single number or every single term has a position. For example, this is the position 1, position 2, 3, 4, 5, and so on. Okay, so a sequence is a list of numbers following a certain rule. Then, if we are talking about arithmetic sequences, we have something very specific like this. Is when we are going to add or subtract the same amount again and again and again. For example, here we have from 2 to 7 and 12, the difference is 4 and 4 and 4 and 4. Okay, or this one, we have 10, 8, 6, 4, 2. So in this case, the sequence is decreasing by 2. Okay, and guess what? The number that we are going to add or subtract has a special name, and the name is going to be the common difference. The common difference. Okay, and by the way, it doesn't matter if we have fractions. We can have an arithmetic sequence or decimals. Okay, we can have something with decimals. For example, something like this, 0.3, then 0.6, 0.9. Okay, so the sequence is following a pattern, a certain rule, adding by 0.3, 0.3. Okay, and again, remember, each number, each term is using a position. Okay, so talking about the common difference, you must know that we can have positive or negative. If the sequence is increasing, like this one, the common difference is positive. If we have something that is decreasing, it's going to be negative. Okay, so we can have something that is an addition again, or a subtraction. Then we have a formula to find any number of the sequence, whatever you want. Okay, this means the number using the position n. At the very beginning, I was saying that every single number has a position. For example, the position 1, 2, 3, 4, and 5. Okay, so this is super important because U1 is always the first number of the list or the sequence. In this case, the number using the position 1. What is n? The position. Okay, what is d? D is the common difference. Okay, the number that we need to add or subtract. Okay, this is the very basics about arithmetic sequences. So we are going to use the equation. We are going to solve this example. Okay, so we need to see this equation in action. So we have this considered arithmetic sequence 6, 17, 28, 39. Okay, explain why this is an arithmetic sequence. Okay, why? Well, always that we have exercises like they say show that this is an arithmetic sequence. So why this is an arithmetic sequence? What we need to do is to perform a subtraction. Okay, we need to take two consecutive numbers here on the list, obviously the sequence, for example 6 and 17. If you remember, they have positions, position 1, 2, 3, 4, 5. Okay, so we are going to take two consecutive numbers. Okay, then we are going to do a subtraction. okay, the number minus the previous one. Pay attention. If we have, for example, the position 2, it's going to be minus the position 1. In this case, 17 minus 6. And what is this? 11. Okay, this is 11. Then, if we take the position 2 and 3, remember, these are the positions, 2 and 3, we have the position 3 is 28, minus the previous position, okay, 28 minus this one, okay, it's going to be 11. The last one, we are going to do again this. What about the position 5 and 4? So we have 50 minus 39, and this is 11. And guess what? This 11 is going to be our common difference. Common difference. Okay? This is our D in the formula. So why this is an arithmetic sequence? Because it has a common difference. And the common difference is 11. That's it. Okay? So that is for A, because it has a common difference. So you should show the subtractions. Okay? Then B, find the formula for its general term. Okay, some students got confused with this. General term, what is the meaning of general term? As you can see, we have a formula for any sequence, but we are going to find the formula for this specific situation and specific sequence. Okay, so pay attention. When we have B, let me see, where is my, here, B, we are going to use the formula. Okay, the number using the position n. Okay, when we have general term, okay, you must think about the position n. N is any position, whatever you want. Okay, any position. So first, u1, remember, u1 is the first number of the sequence. So in this case, number 6 plus n. Okay, remember, n is a position, any position, whatever you want. We are going to find the general term. Basically, this is when the position is n. Okay, minus 1 times the common difference. Okay, so times 11. Okay, in order to find the specific formula for this scenario, the situation, we can do, what we are going to do is algebra. We can simplify this. Okay, we can have 6 plus, remember, we can multiply n times 11. This would be 11n, then minus 1 times 11. This is minus 11. Okay, so here we can simplify. We can say, okay, the number used in the position n, 6. Pay attention, 6. This one, 6 minus 11. This has to be negative, okay, because 11 is bigger. So this is minus, okay, this one, minus 5 plus 11n. Okay, if you want, we can rearrange this like un is 11 times n minus 5. Pay attention with this. This is the general term. If you want to find any position of the sequence, here, the sequence, for example, if you want to find the position, the number using the position 10, we can change n for 10. Okay, so we can use 10 here, and we can find the number using the position 10. So this is B, find the formula for the general term. Then, guys, C, find what? The 50th term, okay? The number using the position 50. So what we can do, let me copy this. Copy. We are going to finding the position n. Here, finding when the position is 50, basically. So what is the number using the position 50? So here comes the trick. the number using the position 50 is going to be 11 times 50 minus 5. Okay, so we can perform this. 11 times 50 is 550 minus 5. So this number is the number using the position 50. Okay, and that's it. This is C. Then what about D? This is a good one. Okay, is the number 325 a member, or we can say a part of the sequence? Okay, this is a little bit tricky. Okay, we have D. Is the number, which number? 325 part of the sequence? This is the question. Okay, how can we know this? Well, you need to check every single term has a position. As you can see, the positions are integers, the position 1, 2, 3. So we cannot have a position with decimals. We cannot have like the positions or the number using the position 5.3. This doesn't exist. So what we can do is to isolate the n, the position, and verify if the position has decimals, is not part of the sequence. If the position is an integer, yes, it is part of the sequence. So basically what we can do here is to isolate, and let me see, isolate n. This is the position. So if you remember, we have a formula for this specific exercise. This one, un, is 11 times n minus 5. Okay, so using this, we can say we already have the number, this one. Okay, remember, this is the number using the position n. So we are going to find the position. We already have the number. The number is 325. We don't know its position. So to show this in an equation, we are going to do this. We have the number times 11 times n minus 5, but we don't have the position. So we need to clear or isolate n by using the opposite operation. So if this is a subtraction, remember we need this one by itself. So we are going to move the negative 5 using the opposite operation. It's going to be an addition. 325 plus 5. This is 11n. Then this number, where is my laser? This one. 11 is multiplying n, so the opposite would be a division. So we have 330 divided by 11. This has to be n. So if we divide this, we have 30 is n. And we need to check here. We have two options. If we have an integer, yes, it's part of the list. If we have decimals, okay, a number with decimals, this is not part of the sequence. So in this case, we have this situation. Yes, the number 325 is part of the sequence and is using the position 30. And that's it. Thank you.